Let's look more at some power functions where the picture is drawn for us so it's a little bit easier to see. We know that these are odd powers because the end behavior is down up. It's going to fall to the left and rise to the right, versus these even powers are going to be up up. Both go out and up to the left and the right. So we can see the power is getting higher, going from x to x cubed to x to the fifth. The graphs are getting more narrow, and same thing going from x squared to x to the fourth to x to the sixth. The graph is getting more narrow as well. So we're gonna write those same summaries that we talked about in the last video, again with just some pictures to reference. If we have even powers, we're looking at x squared, x to the fourth, x to the sixth, and we are symmetric about the y-axis. I can fold them along y and have it match up. They're symmetric about that y-axis. So we're going to write that conclusion in here. And the graph touches and turns at the origin. We touch down at the origin, and then we turn out both ways in a symmetric way. If we look at the odd powers instead, odd powers are symmetric about the origin. So we have to flip on both x and y. If you think about flipping this on just y, we would get to over here, and then we'd have to flip again on the x-axis to bring it down. So again, if you think about it, you flip on the y, you end over here. You flip on the x, it gets you back down here. So that's symmetry about the origin. We have to flip on both x and y to get the graphs to line up. So these are symmetric about the origin, and the graph passes through the origin. And that is something like x cubed, x to the fifth, etc., those odd powers. So even powers are going to touch and turn at the origin and have y-axis symmetry, and these odd powers are going to pass through the origin and have symmetry about the origin.